Your subscribe keeps us motivated. Subscribe now.
A projectile is fired at some angle theta with the speed v0 such that it crosses two walls of equal height symmetrically as shown in the figure. The angle of projection with the horizontal is, you have to figure out what is the angle theta. So basically you are here throwing some object from here, and this object is going like this, okay, and falling down, and at time t equal to 2 seconds, it is at this height, which is at same height from the top, okay. So this part is equal to this part. At t equal to 2 seconds, it is over here, and t equal to 6 seconds, it is over here. The gap between both is 120, right? So 120 is between this point A and point B, correct? Okay. So let's now use the equations. When you are throwing a projectile, what is our equation of motion along x-axis? So x is nothing but u cos theta t. X is u cos theta t, because u cos theta is the horizontal component of the velocity, and at any time later time t, you can figure out its coordinate, x coordinate, using this. So for the first time interval, x1 will be equals to u cos theta t1, and for any time later time, x2 will be equals to u cos theta t2 for any later time t2, correct? Now t1, we know that it is nothing but 2 seconds, and t2 is nothing but 6 seconds, right? So this x1 and x2 is what? x1 is this x coordinate of this position at t equal to 2 seconds when you put here, and here when you put t equal to 6 seconds, you will get this second position, okay, x coordinate. So let's take t1 as 2, or let me just subtract equation 1 and equation 2. So we will get here x2 minus x1, and that will be equals to u cos theta t2 minus t1, correct? When you subtract equation 2 and 1, u cos theta will be common, right? So when you subtract, on the left hand side, it is x2 minus x1, and there t2 minus t1. Now we know that x1 will be from here to here. This coordinate is x1, right? And x2 here is from O to, let's call it as O to B is x2 position, right? Along x-axis, what is the distance moved by the particle? And what is x2 minus x1 given here? x2 minus x1 is given here as 120, correct? And that will be equal to u cos theta, and t2 minus t1, what's the time? 6 seconds, and over there 2 seconds, so 6 minus 2. Let me repeat again. x2 is the distance moved by the particle from O to this position at 6 seconds. What is the distance? x2 along x coordinate. Along x coordinate, what is the distance travelled in 2 seconds? First 2 seconds, it will be x1. So x2 minus x1, the gap is given here as per the diagram 120 meters, right? So u cos theta 120 will be equals to u cos theta into 4. Taking 4 that side, 30 equals to u cos theta. This is our equation number 3. So we got the value of u cos theta as 30. Now these were the conditions when we took our x1, x2 along horizontal direction, how the particle has moved. Now let's see what happened when it is moving along vertical direction. So we know that for vertical direction, the equation of motion will be y equals to u sin theta t, correct, minus half gt square. This is the equation of motion along y-axis. So at any instant t, if you want to figure out where will be the particle along y-axis, correct, you can use this equation. So let's put here y1 at the time when t1 was 2 seconds, the y coordinate will be u sin theta t. What is t? Minus half gt square. T is how much? Correct. And similarly, this is our, let's call it as equation number 4. Similarly, y2, the position coordinate of the particle or the projectile when it was at B. So u sin theta, and distance time is how much? 6 seconds minus half g 6 square. I hope this is clear. Okay. So this is our equation 5. Now let's go back to the diagram and understand the next concept. Now, if you look at the y coordinate, this is our y coordinate over here, y1, and this is our y2 coordinate over here. Now, understand the core concept here. The y1 coordinate is exactly equal to y2 coordinate. Sir, why it is so? If you look at this, this is the height. So, height here is h, let's say, or instead of putting, they have taken h, so let's call it as h1, and here the height is h2. This h1 and h2 will be same from the ground. So, from the ground, the vertical distance of the particle at 2 seconds and 6 seconds is exactly same. Let me repeat again, this is the most important part. At t equal to 2 seconds, the particle is at the same level from the ground as it is at t equal to 6 seconds. So, let's substitute these values, okay, over here. So, y1 is equals to y2. So, let's put here y1 equal to y2, and putting y1, what is y1? 2u sin theta, I have taken 2 in front, minus 2 to the 4, 2 cancels, 2g is equals to 6u sin theta, and 6 is a 38, 36 by 2, which is 18g. I hope this is clear. So, I have taken equation 4 and equation 5, I have equated and simplified it. So, here taking 2u sin theta on the other side and 18g on the left hand side. So, 18g minus 2g, that will become 16g, and 6u sin theta minus 2u sin theta, that will be 4u sin theta. I hope this is clear. And from here, u sin theta is nothing but 16g over 4. So, u sin theta is nothing but 4g. I hope this is clear. So, u sin theta is 4g, and look at equation 3, u cos theta is 30. If we divide equation, this is equation 6, let's say. So, divide equation 3 and equation 6. So, 3 and 6, that will give us, so let me divide 6 upon 3rd, 6 is u sin theta upon u cos theta, and u sin theta is nothing but 4g, and let's see what is u cos theta, that is 30, correct? So, that will be 30, and let me just put here 4g as 4 into 10, correct? So, 4 into 10 is how much? 48. G value I have taken 10, correct? So, our u and u cancelled. This implies tan theta is nothing but 4 by 3. Now, if tan theta is 4 by 3, then theta is nothing but 53 degree. For 53 degree, look at this triangle. If this is 53 degree, then this is 3, this is 4, and this is 5. So, theta must be 53 degree. Yes, understood?